Example 1c. So again, we want to find the area which is enclosed by two curves and is also between two limits that are on the y-axis. So because the limits that the area lies between is on the y-axis, we have to use a different formula for that area. So the area A equals the integral, and the limits are A and B. Remember, these are y limits, and because the limits are y limits, it's the curve that's to the right of the area. Subtract the curve that's immediately to the left of the area, and be careful at this stage, we're integrating now with respect to y, because the limits, remember now, are y limits. So the next thing is we need to get the curve that's immediately on the right and the curve that's immediately on the left in terms of y. Okay, so in other words, we need to make x the subject of these two curves. So let's take the curve that's on the right. These two separate curves all belong to y equals 1 over x squared. So if we start with the one that's on the right, we're going to rearrange it to make x the subject. So I'm going to put y over 1 and cross multiply. So we're going to get x squared y is equal to 1. Divide both sides by y. So we're going to get x squared equals 1 over y. Now I'm going to take plus or minus the square root of the other side. So x equals plus or minus the square root of 1 over y. Now we can tidy that up a wee bit more. We can break up the square root, so we can take the square root of the top line and the square root of the bottom line. So that would be plus or minus the square root of 1 is just 1 all over the square root of y. Just to tidy it up a little bit. Now, which version are we going to use? Well, the curve here that is to the right of the y-axis, we take the positive square root. So we're going to use x equals positive 1 over the square root of y, because the curve is to the right of the y-axis. Now the good news is, because we've done so much work there, we now know what the curve is to the left, because we're rearranging the same curve as we had before, but this time we're going to use the negative square root. So the curve to the left, we're going to use x equals negative 1 over the square root of y. Again, that curve is to the left of the y-axis. So we're now ready to find the area. So the area A equals the integral. So the limits are y limits, so the limits are between 1 and 4. So smaller limit goes on the bottom, bigger limit goes on the top. The curve on the right is positive 1 over root y. We're subtracting the curve on the left, which is negative 1 over root y. And we're integrating with respect to y. Okay, let's tidy up. Again, we're multiplying a minus by a minus, which will become a plus. So we've got positive 1 over root y plus another 1 over root y. We're going to have two 1 over root y's. So that's going to be just 2 over root y. Okay, now, problem. Well, two issues. We can't integrate until we get rid of the roots, and we also get y to the top line. So remember, the square root of y is the same as y to the power of a half. but we want to get this y to the power of a half to the top line, so we're going to slide it to the top but change the sign of the power. So that's going to give us the integral between 1 and 4 of 2y to the power of negative a half, and then we're integrating with respect to y. So we're good to go now, we're ready to integrate. So we're going to use square brackets because there's limits now. So add 1 to the power, divide by the new power. So we're going to have 2y to the power of positive a half, and then we divide by that new power of positive a half. We add on our constant, close our square brackets and put our limits outside. So dividing by a half is the same as multiplying by 2. So that's the same as 4y to the power of a half plus c. And then our limits stay outside. Now we're going to break up the square bracket into two separate square brackets with a minus between them. So we're going to chuck the top limit into the integrated expression in the first square bracket. So we're going to have 4 times 4 to the power of a half plus c. And then we're going to chuck the bottom limit into the integrated expression in the second square bracket. So we're going to have 4 times 1 to the power of a half plus c. Okay, let's tidy all of that up. So 4 to the power of a half means we're just taking the positive square root of 4, which is 2. So 4 times 2 is going to give us 8. So we've got 8 plus c. And then we're subtracting 1 to the power of anything is just 1, or the positive square root of 1 is just 1. So we're left here with 4 plus c. And again, the c's always wipe out because this bracket's being multiplied by a negative, so c minus c is gone. So we're just left with 8 subtract 4, which is just going to give us 4 square units. So in other words, what we've done is we found this enclosed area right here. So this enclosed area is 4 square units. Now the drawing isn't great, but the curve should be symmetrical about the y-axis. So this section here to the left of the y-axis should be exactly the same as the section to the right. So these two sections must be worth 2 units each for the overall to be 4 square units.